Okay everyone, welcome back. So today we are looking at our binomial probability distribution, and in particular looking at expectation, variance and graphing. First of all, we need to remember exactly what a binomial probability distribution is and what properties it has. So our first one was that we can only have two possibilities, which are either success or failure. So that's our first thing that we're looking at. Our next property is that the probability of success does not change. Okay, so that's our second thing there. And our third criteria, which we're looking at, is that there are n independent trials. Okay, so we have a number of trials, but they are independent. So this is what we're looking for. Once we know that we've got a binomial probability distribution occurring, then we can perform a number of other mathematical tasks. So our first one is that we're going to draw a graph to reflect the binomial probability distribution. And we're going to use our CAS calculator to do this. So I've got my calculator here. I'm going to need you to go through the particular steps that are required and write them down so you've got them there to follow, and we will go from there. So first of all, if we go back to the menu, we need to be looking in the graphs and tabs menu. Okay, within here, in our Y1 position, we are going to write down a particular function. So what we're going to need to do, and I might just come back here for a second, within here we're going to be, within this section here, we are going to be entering binomial, PDF, and we're going to need to enter our x value, our n value, then our p value. So for this particular example, if we come back to find binomial, obviously we don't have the interactive menu where we normally find it. The other way to find it is to look in keyboard. In catalogue, we go to the B section, we find binomial PDF. Not binomial P. Let me have another try here. Further down, binomial PDF. In this case, our value of x is going to be changing as we go. It's going to be something different, so we just leave it as an x. Comma, our next value that we need, n, our number of trials. In this case, it's written over here. Our number of trials is 20. And our probability of success, which is written here, is our 0.3. So this we have defined. Press execute, make sure that our little box here is ticked. What we're going to do first now is to form these values in a table. So to form in a table, we look here and we click this little button just here, which gives us a table, a range of values. So therefore this is saying the chance of getting a 1 is equal to, if we think about what this means, 6.8. So let's just think about this for a second. Hopefully you do remember. 6.8 e to the power of -3. What that actually means, it's in scientific notation, means times 10 to the power of -3. Which means if I was to move my decimal place 3 places to the left, I'd end up with 0.0068. However, we have here only 5 values of x. If we've got 20 trials, that means that we really should have 20 different values of x. If we're completing our probability distribution, we would have 20 different values. This is actually quite a nice way if you ever need to create a table of values for the binomial probability distribution function, and if it's fine to do so in decimal places, this is a way that you could calculate all those values quickly. So to extend the table, we come up here, we click this button with the x's and the y's. We start at 1. In this case, we want to end at 20. Our step is still 1. We're going up by 1. And we now have all of our different values here. Okay, and we can see that they do start getting quite low towards the end, which makes sense. We then want to actually graph this. So to graph it, we're going to click on our graph menu here. We do need to think really carefully about our scale. So in terms of our scale, our x values, we're going to be starting at 0 and going to 20, because that was our range of n, our number of trials. Actually, that reminds me, let's come back to our table here for a second, because our table, we can start at 0, can't we? We can have a 0 value. Okay, so back to our graph. Our scale, that's our table, sorry. Here's our y values here. We're wanting to go from 0 to 20 for our x values, with a scale of 1 going up by 1s. Our y values from 0 to, what was our top table value? So I'm going to go with 0.5 and increase by 0.1. So we've now got a lovely binomial probability distribution. When we're drawing this graph, as you can see, some values are quite low, that they are almost on the axes. That's fine. We can draw them on the axes when they're very, very close to 0. So let's actually draw this graph. So we have our axes, and you really should be drawing this with a ruler, using a careful scale and so on. So remember how I was drawing it there. We were going from, each of my parts here was 0.1, 0.2, 0.3. So if we're thinking of that, it looks like nothing gets higher than 0.2. So we're going to go 0.1, 0.2, and these are our probability values, our x values. So we have 0, 1, 2, 3, 4, and you should be drawing this in yourself as well. Okay. If you've got a ruler, drawing an accurate scale would be a much better idea than the way that I am doing this here. So I do definitely recommend that. We label our axes. This is our x. So for 0, our first point was 8.0 times e to the power of -4. That's going to be very, very close to 0. So I'll put that on our axes here. I might do this in another colour to make it clear. So we've got 0 here. Our second one was just above, and we do tend to use just straight lines to represent that. At 2, we have a value of 0.02, so it's a little bit higher. So we're reading off the graph here or the table at 3, 0.07, so we're getting up higher there. At 4, we've got 1.3, so this time we've gone above our level of 1. At 5, we had 0.17, so that's going to be up higher again. And if you've got a ruler, I would definitely recommend that. We can have a look at the rest of our values here. At 6, we're going to 0.19, so this is almost right up at 2, so pretty close to 2. And again, please do use a ruler if you've got one. 0.16. At 8, we've got 0.114, just past there. At 9, 0.065. 0.03, 0.1, and soon we're going to be getting very close to 0 again. So at 11, we've got that one there. At 12, and the rest of them are going to be pretty close to 1. Now I hope that when you draw this, yours does look a little better than mine. Using a ruler will allow you to be much more accurate in how you're drawing your lines. But essentially that's how we come up with the graph of the binomial probability distribution. I highly doubt that you'll ever actually have to draw it yourself, like I've just done there, but you might need to be able to interpret it. So being able to put it on your calculator is definitely very useful. So let's move on to our second concept for today. We're looking at expectation and variance. So if we're wanting to calculate our expected value, remember this is the same as the mean. Okay, so another notation is mean. And we've got n and p. Hopefully you recall that n is our number of trials and p is the probability of success. Okay, so this is on your formula sheet. You don't need to remember, and it's actually quite a nice easy formula to use. Our variance, np times 1 minus p, and remember this value here, 1 minus p, is also the same as our Q value, the probability of failure. We might need to work out our standard deviation, and hopefully you remember our standard deviation is still just the square root of the variance. So let's answer these particular questions here. In the methods exam, there are 20 multiple choice questions and there are 5 possible options for each. If a student guesses one randomly, how many would they expect to get correct? So our probability of success, in this case success would be choosing the correct answer when we choose randomly. There is one correct answer out of there are 5 multiple choice options. N, our number of trials, we are guessing questions 20 times because there are 20 multiple choice options. Our expected value, all we need to do for our expected value is N times P, so 20 times 1/5, so we would expect to get 4 questions correct. Not very many, so I wouldn't actually recommend this strategy, just purely guessing. Okay, we now want to interpret this particular interval here, the mean minus 2 times the standard deviation. So let's first work out the standard deviation. If we start by working out the variance is equal to our N value, which is 20, times P, which is 1/5, and then 1 minus P. So if we are working this out, we've got 20 times 1/5 times 4/5, which will give us 4 times 4 over 5, which will give us 16 over 5. We then work out the standard deviation, which is the square root of that. And at this stage, I haven't said so here, but let's do it correct to 2 decimal places. So if we go back to our main menu, let me just find it here, back to our main menu, okay. We're wanting to work out the square root. The square root of 16 over 5. We're putting it in decimals, and we get our answer there, 1.7855. 1.78, let's round it to 3 decimal places. So to interpret this interval here, our mean minus 2 times the standard deviation, we need to calculate this interval first. So when we calculate this, we're taking our mean, which we had before. Our mean, remember, is the same as our expected value. It's our answer to part A. So our mean is 4. So we've got 4 minus 2 times our value from here. And the other one is going to be the same, but we're going to add 2 times the standard deviation. Okay? So what we get therefore is that our values here, we need to go between 0.422 up to 7.577. Remember, this interval is always approximately equal to 95% of the values. So the way that 1.57, we're expecting 95% of students to get this correct. So that means it is highly likely that if everyone was guessing that they would get between 1 and 7, if we're rounding, between 1 and 7 multiple choice questions correct when they're guessing. Personally, I think that is not a very good rate, so I'd recommend that you don't use that strategy. Our last example for today. So in this case, we've been told for a particular random variable x, the mean is 12 and the variance is 9. So that means our mean is equal to, or we could write it as expected x, means the same thing, is 12, and our variance is 9. We know that the mean is equal to n times p, and our formula says that our variance is equal to np1 minus p. From here it's really straightforward, we just need to solve these. We can solve them by hand, by doing our second equation divided by our first equation, or if we're in Tech Active, even quicker and easier, we can solve it on our CAS calculator. I'm going to come here into our variable menu, so we're going to have NP equals 12, and then down here we're going to have NP 1 minus P equals 9, and we're wanting to solve this for n comma P. And we get an answer of n is 48, and our p-value, which has just disappeared off the side there but was 0.25. We then want to find the value of this. Remember, when we're finding probabilities, our notation is that we say our function is binomial, our little squiggly line. Our n value is 48 and our p-value is 0.25. And we're trying to calculate the probability that x is equal to 8. Let's just do it on our calculator again, the quicker, easier way. Interactive, distribution, discrete. We're doing binomial PDF because we're just wanting one value. Our value of x is 8. Our trials, we've figured out our n is 48. Our probability of success is 0.25. And we click OK. And we've worked out, therefore, the probability of getting x equals 8 in this case is equal to 0.0579. So that's all that we need to know. Have a go of these yourself. If you have any questions, come and see me. Thank you very much for watching.